So, after your journey into the beginning of the universe and the solar system, you will now find out how the early Earth was formed and how it evolved into its present state. And scientists were able to reconstruct the sequence of events in Earth's history from the fields of petrology, stratigraphy, and paleontology. So it includes the study of fossils to determine how they evolved and interacted with the environment. So for this chapter, we will be discussing about the Earth's history. So the main or the big idea is that Earth underwent evolutionary processes that can be described in terms of geologic time. And in this chapter, hopefully you guys will be able to describe how layers of rocks are formed, explain how relative and absolute dating were used to determine the subdivisions of geologic timeline, describe how index fossils guide fossils are used to define the subdivisions of geologic timeline, and describe the history of the Earth through geologic time. Okay, so for the first lesson, we will be discussing about the differentiation of early Earth. So, in the previous discussion, you learned that the solar system began to form approximately 4.5 gigaannum from a disk of dust and gas around a young sun. So, based on the meteorite estimate, Earth is believed to have formed over a period of 100 MA since the beginning of the solar system. So as the Earth condensed during its early stages of formation, gravity caused the rocky fragments and planetesimals to accelerate. So this caused them to collide at high speeds and converting the kinetic energy into thermal energy, which warmed up the early Earth. Additionally, the collision of asteroids, of comets, and more planetesimals into the Earth's surface also provided heat. So, beside the two mentioned processes, there is also an internal heating associated with the radioactive decay on the Earth's interior. So, the radioactive decay refers to the process wherein unstable atoms emit energetic particles and gamma rays that heat the surrounding rock. So, these processes caused the early Earth to become so hot that it became a hot mass of molten matter. So, moreover, due to gravitational force, denser substances such as iron and nickel sink toward the center in the process called planetary differentiation. So, the less dense materials such as sodium and potassium and also calcium, including some silicates, it moved upwards to form the mantle and the crust. So this separation of materials creates the compositionally distinct layers of Earth, each with their unique physical chemical behavior. So today, the geosphere consists of three major layers, which are the core, the mantle, and the crust. So in this picture here, you will see the different layers of the Earth.